students. So what we have discussed in the previous class, Amma? Hello guys, is my voice audible?
Yes, ma'am.
Yes, ma'am.
What about the screen? Is it visible or not?
Yes, ma'am.
Yes, ma'am.
What
It's
we discussed in previous class, problems on Lagrange's mean value theorem. Okay, so we have discussed the different types of problems in Lagrange's mean value theorem, right? Okay, now coming to the next question. Is this problem over?
Yes, ma'am. Yes, ma'am.
Okay, now coming to the next question. Using mean value theorem for 0 less than a less than b, prove that 1 minus a by b is less than log of a by b is less than b by a minus 1. And hence show that 1 by 6 less than log of 6 by 5 less than 1 by 5. Okay, so here we have deduction also there. So we have to do this problem. Okay, so coming to the next question. So the question is, see, using mean value theorem, for 0 less than a less than b. Okay, so prove that 1 minus a by b is less than log of b by a is less than b by a minus 1. Okay, and hence show that we have deduction also there. So that is 1 by 6 is less than log of 6 by 5 is less than 1 by 5. Okay. Okay, so how to do this problem? Before that, tell me what is the function.
Log X.
log X.
So what is, hello? Okay, what is our function here?
Log X, ma'am.
So here our function is log x, right? So f of x equal to log x, isn't it? F of x equal to log x, and the limits are here a to b, ab. Okay, so by using mean value theorem means here we have to use Lagrange's mean value theorem. Okay, so we have to use Lagrange's mean value theorem, isn't it? So by Lagrange's mean value theorem, so So what is our first condition? What is our first condition?
F of x is continuous in closed interval a comma b.
F of x is continuous.
X is continuous in closed interval a
A
comma
comma
b.
B. Okay. Continuous in closed interval a comma b. And the second condition is f of x is differentiable
X is differentiable
in open
a comma
interval
b.
a comma b. So f of x is differentiable means f dash of x exists in open interval a comma b, right? So what is f dash of x? Log x differentiation is
1 by x.
1 by x. Log x differentiation is 1 by x. It exists. It exists in open interval a comma b. అది మ్యామ్ది కదా ప్రవీణ మ్యామ్ ఆ మిడిల్ లో తీసుకెళ్ళి So f dash of x that is equal to 1 by x exists in open interval a comma b. So then what we have to do? Then there exists by using Lagrange's mean value theorem. What is the main formula?
F dash is equal to
F dash of c equals to f of b minus f of a by b.
By Lagrange's mean value theorem, f dash of c equal to f of b minus f of a divided by b minus a. Okay. So what is f dash of c, Amma? What is f dash of c?
1 by c.
1 by c.
1 by c. What is f of b? And what is
Log
f
b.
Log c. Log b minus
log
log
b
a by b minus.
minus log a divided by b minus a. Okay, let us consider that is equation 1. Okay, so now coming to the next step. So we know that we have one more condition is there. So it is continuous, differentiable, and the formula is there along with c belongs to open interval a comma b, right? So c belongs to open interval a comma b means a is less than c is less than b. Okay, so we have to convert this c to 1 by c, isn't it? How to convert?
Reciprocal.
Reciprocal sign change.
Then
Sign will be
Less
changed.
than changes to greater
the
than.
sign will be changed. So 1 by a is
Greater than.
greater than 1 by c is greater than 1 by b. Okay, now from equation 1, substitute 1 by c value, right? So what is 1 by c? That is log b minus log a divided by b minus a, okay, is greater than 1 by b. Okay, so 1 by a is greater than log b minus log a divided by b minus a. Okay, then what we have to do?
Multiply by b minus a.
In the form of like this, multiply with b
B
minus
minus
a on
a.
both sides is greater than log b minus log a is greater than b minus a by b, isn't it? Okay, next. So what is the formula here? We have to use one formula. What is that formula, Ma?
Log b minus log a equal to log b by a.
Yes, according to log a by b formula, that is nothing but log a minus log b, isn't it? So log a into b is nothing but log a
Log b.
plus log b, isn't it? Okay, so according to first formula, we have to write that is b. Here I am simplifying this one. So that is b by a. See, so this is b by a minus a by a is 1 greater than. So this is log b by a. Okay, so according to this formula, log A by B is nothing but log A minus log B. Okay, so log B minus log A, this is log A, is nothing but log of B by A is greater than, so B by B is 1 minus A by B. Okay, so is this in this form? No. So then you have to interchange. So, or you can write in the reverse order, this will be like this. So B by A in the reverse order. B by A minus 1. So hence proved.
Yes, ma'am.
Okay. So coming to the deduction part. So for the deduction part, what we have to do? So what is our deduction? This one, right? So from that, can you tell me? So let us consider this is equation 2. Before that, let us consider this is equation 2. In equation 2, we have to put A value and B value.
B
A
values
value and
B
B
is
value. What
6,
is
A
our
is 5.
is
B is, so which will be in the form of log B by A, right? So in the numerator, we are having B. So that's why what is B value? B is 6. Okay, so in the denominator, we are having A, right? So that's why A value is 5. Okay, so now put A equal to 5 and B equal to 6 in equation 2. In equation 2. So then that is 1 minus 5 by 6 is less than log of 6 by 5 is less than 6 by 5 minus 1. Okay. So after a simplification, 6 minus 5 by 6, that is nothing but 1 by 6 is less than log of 6 by 5 is less than 6 minus 5. So that is 1 by 5. Okay. Hence proved.
Hence proved, ma'am.
yes, ma'am.
Very good. That's it. Okay. So, shall I erase the screen, guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So, all of you try this problem. show that for any x greater than 0, 1 plus x into 1 plus x in 1 plus x is less than e power x is less than 1 plus x into e power x. 1 plus x into e power x. So here what is our function?
E power x.
E power x.
So what is the differentiation of e power x?
E
E power x.
E power
E
x.
power x.
Okay, so f of x is equal to e power x and f dash of x is also equal to e power x. So all of you do this problem, do it fast. So after that, tell me what is b value and what is a value. This is our deduction, Amma, actually. This is a deduction part.
Ma'am, A value is 0 and X value is B value is X.
What is A value? Who's that? What is A value and what is B value, guys?
A value X, ma'am.
83. A value is
0.
0. What about B?
B is X, ma'am.
B is
Very,
X.
very good. Mm. So here function is, what is our function? F of x equal to e power x, isn't it? In closed interval, first we have to write the intervals are a comma b, okay? And it is continuous, means f of x is continuous in closed interval a comma b, and it is differentiable. It is means f of x is differentiable in open interval a comma b, right? So then there exists. So before that, so f dash of x differentiable in open interval of a comma b is nothing but f of x exists. in open interval a comma b, right? So f dash of x equal to also e power x. Okay, so f of x is e power x and f dash of x is also e power x in open interval a comma b. Okay, so by Lagrange's mean value theorem, so this is also most important question, Amma. So that is f dash of c equal to f of b minus f of a divided by b minus a. Okay, so what is f dash of c? E power c. Okay, so this is e power b minus e power a divided by b minus a, because f of x is e power x and f dash of x is also e power x, right? Isn't it? So let us consider this is equation 1. So then, so what is our next step? So this is our most important step, that is c belongs to open interval a comma b. So from that a less than c less than b. So we have to take, what is our next step?
C power A less than E
Hmm.
power C.
E power a is symbol will change or not? No,
No, ma'am.
e power b. Okay, so instead of e power c, we have to substitute that value from equation 1. Okay, so then you will get e power a is less than that is e power b minus e power a divided by b minus a is less than e power b. So now multiply with b minus a on both sides. No, multiply kada. So multiply with e power a b minus a on both sides. So that is b minus a into e power a is less than e power b minus e power a is less than b minus a into e power b, isn't it? Okay, so next, so what we have to write? So b minus a, now let us consider this is equation 2. Now substitute, what is a value? A is 0, b is
B.
x in equation 2. Okay, so then we get, so after substituting, b is x minus a is 0 into e power 0 is less than next, what is our next value? So this is e power b value, that is x minus e power 0 is less than b is x minus 0 into e power b, that is x. Okay, so this is x into e power 0, that is 1, and e power x, that is 1, is less than x into e power x. Okay, so add 1 on both sides, then you will get 1 plus x is less than e power x is less than 1 plus x into e power x. Hence proved. Sorry.
Yes, ma'am.
So next, I will give you one more question. So now hence proved. Shall I raise the screen?
Yes, ma'am.
Yes, ma'am.
So all of you do this problem as homework. Show that h is less than e power h minus 1 is less than h into e power h. Okay, so where h not equal to 0. So all of you do this problem as homework along with the show that one more question is there. So 1 by b is less than log b divided by b minus 1 is less than 1. Okay, where b greater than 1. Where b greater than 1. Okay, so if I substitute instead of b 1, no, then that will be infinity, right? So that's why the condition is here b greater than 1. So all of you make a note of these two questions. All of you do as homework problems. Next. Shall I wipe up the screen?
Yes, ma'am.
So can you tell me how to do this problem? Okay, so prove using mean value theorem. Mean value theorem, that is modulus of sin u minus sin v is less than or equal to modulus of u minus v. Modulus of sin u minus sin v is less than or equal to modulus of u minus v. So what is our function here?
Sin x.
What is the differentiation of sin x?
Cos x.
Cos x.
Cos
What about the limits?
uv.
UV.
UV
Hmm?
ma'am.
uv.
uv or so what is the main formula? F dash of c equal to f of b minus f of a divided by b minus a. So here the function is f of x is sin x, right? So what about f dash of x? That is cos x. Okay. So f dash of x is nothing but that is cos c, that is equal to sin b minus sin a divided by b minus a. Okay. So but here we are having u and here we are having v. So what is a value? A is v and b is
Is
u. Okay, na? Here the limits are, otherwise you can write the limits here. So v comma u. Here the limits are a b. So a is v and b is u. Here the limits are v comma u. So all of you try this problem. So in this question we have to use one condition. So that is there in your intermediate. So that is the formula. So in this case, we have to use the modulus of cos x formula. Can you tell me what is modulus of cos x? Modulus of cos x. What is the formula for modulus of cos x? Yes, yes. What happened, guys? So modulus of cos x is always less than or equal to 1. Okay. Modulus of cos x is always less than or equal to 1. So what is our function Amma here? Here our function is
sin x.
Sin x.
f of x equal to sin x. So what about the limits? In directly here I am writing v comma u. Okay, here the limits are v comma u. Okay, so it is continuous. F of x is continuous in closed interval v comma u. And the second step is f of x is differentiable. F of x is differentiable in open interval v comma u. Okay, so what is the meaning of this? F dash of x exists in open interval v comma u. So what is f dash of x? Sin x differentiation is cos x. So that exists in open interval v comma u. Okay, so by Lagrange's mean value theorem, so what is the formula? The formula is here f dash of c equal to f of b minus f of a divided by b minus a. So what is f dash of c? So here we are having f dash of x value. F dash of x is nothing but cos x. So then f dash of c is cos c. So cos c equal to what is f of b?
Sin u minus sin v by
Sin v minus sin u by
Sin u minus sin v. Because here A is v and B is u. Okay.
this one.
So A is v and B is u, and f of x is sin x. So that's why this is sin u minus sin v divided by
U minus
u minus v. Okay. U minus v. Okay. But here we have to use one condition. So what is that condition? We know that the condition is modulus of cos x is less than or equal to 1. Okay. So after this step, we have to write one more step. Okay. So that is take modulus on both sides. Take modulus on both sides. So that is modulus of sin u minus sin v divided by u minus v. Okay. And so next step, in the next step here I am writing modulus of sin u minus sin v divided by u minus v is equal to modulus of cos c. Okay. So after that I am writing this condition. So that is modulus of cos x is less than or equal to 1. So that means modulus of cos c is less than or equal to 1. If I substitute modulus of cos c is less than or equal to 1, no, then the condition will be, or this equation will be like this, right? Less than or equal to 1. Okay. So from this step directly we can write therefore modulus of sin u minus sin v is less than or equal to modulus of u by u minus v. Okay. Hence proof. So in this step, in this problem, so this step is plays a vital role. Okay. So remember this step. So the formula is here: modulus of cos x is always less than or equal to 1. Modulus of cos x is always less than or equal to 1. So don't forget this condition, but this problem. Shall I erase the screen?
Yes, ma'am.
So all of you try this problem. Using Lagrange's mean value theorem, Lagrange's mean value theorem, prove that tan x is greater than x in 0 less than x less than pi by 2. Okay. So what is tan pi by 2?
not defined.
Tan pi by 2 is?
Undefined.
Not defined.
Yes, not defined means that is infinity. So that's why here they are not giving pi by 2 value. Okay, so here the limits are 0 less than x less than pi by 2 only. Okay. So in these limits only tan x will be exist, or tan x is applicable for in these limits, that is 0 less than, in between the limits. Okay, 0 less than x less than pi by 2. So if 0 less than or equal to x is less than or equal to pi by 2, no, so at pi by 2 tan pi by 2 is infinity. Okay, so that's why the limit should be 0 less than x less than pi by 2. Okay. So here what is our function?
Tan x.
Tan x. What is the differentiation of tan x?
Secant square x.
Secant square x. Very good. So is there any formula regarding secant square x?
Secant square x minus tan square x.
No. Chala formulas ఉంటాయి. But here we have one condition or one formula for secant square x. So that is secant square x is always greater than 1. So in previously we have used one condition. What is that condition? Modulus of cos
Modulus
x
cos
less
x
than
less
or
than or
equal to
equal
1. Okay. So in this problem we have to use secant square x greater than 1. Secant square x greater than 1. Okay. Use this formula. So procedure, everything is same. So how can we do this problem? So here our function is, so given that f of x equal to tan x. Okay. So that is defined in, here I am taking just a comma b only. Okay. A comma b limits. And we know that f of x is continuous in open interval, closed interval a comma b. And second case is f of x is differentiable in open interval a comma b, right? So that means f dash of x exists in open interval a comma b. Okay, so what is f dash of x? F dash of x equal to f of x is tan x. F dash of x is
Secant square.
secant square x.
secant square x. Okay, so that is exists in open interval a comma b. Okay, so by Lagrange's mean value theorem, what is the formula? F dash of c equal to f of b minus f of a divided by b minus a. Okay, so what is f dash of c?
Secant square c.
Secant square c is equal to, what is f of b?
Tan b minus tan a. By
Tan
b
b
minus.
minus tan a divided by b minus a. Okay, so tan b minus tan a divided by b minus a. Okay, so what we have to do? What we have to do?
Condition.
Yes,
You don't know, ma'am. Condition secant square x greater than or.
so we have to use this condition. So by, or we know that, what is that condition? Secant square x is greater than 1. Okay, secant square x is greater than 1. So you have to substitute secant square c is greater than 1 here. Okay, so then the condition will be tan b minus tan a divided by b minus a is greater than 1. Okay, so this is from equation 1. So from equation 1, we get tan b, if secant square x is greater than 1, from equation 1 we get, that is because we know that the secant square x or secant square c value is tan b minus tan a by b minus a. Okay, so then tan b minus tan a divided by b minus a is also greater than 1. Okay, so from this we can write tan b minus tan a is greater than b minus a. Tan b minus tan a is greater than b minus a. So now tell me, what is a value, what is b value?
A value is 0, B value is X.
Okay. So now put a equal to
0,
0 and b equal to
X.
x in equation 2. In equation 2, we get. So that is tan x minus tan 0 is greater than b minus 0. Sorry, b is nothing but x, right? So x minus 0. So from this we can directly write tan x is greater than x.
Hence
Okay.
proved.
Then that's it. Isn't it? Is it clear, all of you?
Yes, ma'am.
Yes, ma'am.
So shall I give you one question? So can you tell me how to do that problem? Shall I erase the screen?
Yes, ma'am.
Yes, ma'am.
So all of you take the screenshot, that is better. Okay. So the question is, this is also important question. If f dash of x is equal to 0, throughout an interval, throughout an interval, throughout an interval, closed interval a comma b. Okay. So prove using mean value theorem, that f of x is a constant. F of x is a constant in that interval. In that interval. Okay. So here, what we have to take for the function?
Constant.
Constant.
So here f of x is a constant. Constant differentiation is
0.
0. So that's why they have mentioned that like this. F dash of x is 0. So because here f of x is a constant, we know that constant differentiation is 0, right? Same procedure you have to do. So by using Lagrange's mean value theorem, here f of x is a constant and it is continuous in closed interval a comma b, and it is differentiable in open interval a comma b. So that means f dash of x exists in open interval a comma b. So f dash of x is nothing but here 0.
0.
They mention, if they had not mentioned also, we know that f of x is a constant means f dash of x is
0.
0. F dash of x is 0 because we know that constant differentiation is 0, right? So f dash of x is 0. So by Lagrange's mean value theorem, what is the main formula? F dash of c equal to f of b minus f of a divided by b minus a, isn't it? F dash of c equal to f of b minus f of a divided by b minus a. And what is f dash of c? We know that f dash of x is 0. So from that f dash of c is also 0, right?
0. Yes, ma'am.
Okay. So that means 0 equal to f of b minus f of a divided by b minus a. So from that we can write f of b minus f of a equal to 0. F of a equal to f of b. So what is the meaning of that? So from that we can conclude that if f of a equal to f of b means, therefore
F of x is constant.
x is a constant. Okay.
Yes, ma'am.
From that we can conclude that f of x is a constant, then only the differentiation will be 0. Okay. So all of you do that problem. This is also most important question. So here, so here let f of x is a constant that is defined in closed interval a comma b. So satisfies Lagrange's mean value theorem. Okay. So and f of x is continuous in closed interval a comma b. And second one is f of x is differentiable in open interval a comma b, and f dash of x exists. So differentiable means f dash of x exists in open interval a comma b. Okay, so what is the, here we know that f of x is a constant, right? F of x is a constant. Let f of x is a constant means constant differentiation is 0. Okay, so that exists in open interval a comma b. Okay, so by Lagrange's mean value theorem, what is the formula? F dash of c equal to f of b minus f of a divided by b minus a. Okay, so f dash of c is 0 and we don't know about f of b minus f of a divided by b minus a. B minus a, right? So from that we can write f of b minus f of a equal to 0 and that is f of b equal to f of b, a. Okay, so from this we can conclude that f of x is a constant. Then only the constant differentiation will be 0. Okay. Shall I erase the screen?
Yes, ma'am.
Yes, ma'am.
So all of you try this problem. This is also most important question. Calculate approximately. Calculate approximately fifth root of 245. Fifth root of 245 by using Lagrange's mean value theorem. So can you tell me what is our function here? So always the given value or middle value is b value, right? So here fifth root of something is b value. What is that something?
X.
245. That is b value. Now tell me what is our function?
Root x.
Root x.
Yes.
X power 1 by 5.
Yes, very good, very good. So what is our function? Here our function is fifth root of x. Okay, our function is fifth root of x. So that is nothing but x power 1 by 5. Okay, so what is the difference? This is our function. So what is the differentiation of f dash of x?
1 by 5 x power minus 4 by 5.
Differentiation of x power n is nothing but n into x power n minus 1. Okay, so that is 1 by 5 x power 1 by 5 minus 1.
That's 1.
So that is 1 by 5 x power minus 4 by 5. Yeah?
Yes, ma'am.
Okay, so all of you try this problem. Same procedure you have to use. So otherwise we'll discuss in the next class. Okay, so this is our last problem in Lagrange's mean value theorem. Okay. So after that, Cauchy's mean value is the theorem is there. So that is our last topic in module 3, first chapter. Okay. So it will take 30 minutes, around 30 minutes for Cauchy's mean value theorem. Okay. We'll finish our syllabus on Monday. Okay, Amma. Thank you. Any doubt?
Attendance
No.
Attendance.
66, 69, 88, 94.
Okay, na?
Yes, ma'am. I'll send it to you on WhatsApp.